This is Vin Urbanowski from AITE in Stamford, Connecticut, and this is NASA Now.
What that does on an asteroid is the astronauts read out the gravitational effect of those planets.
Hi, I'm Matt, and this is NASA Now. NASA is focusing its energy on deep space exploration. So, it's no surprise that some of NASA's greatest scientific minds and experts are hard at work developing incredible new ways to support and sustain missions lasting longer than 6 months. Sound amazing? Wait till you see what's on the drawing board. That's ahead. First, here's what's happening at NASA Now. A host of NASA satellites played a key role in helping scientists and weather forecasters plot and plan for the largest superstorm in modern history. Images captured by NASA's Terra satellite on October 26 revealed Hurricane Sandy's enormous size. NASA's CloudSat and Tropical Rainfall Measuring Mission satellites captured detailed data revealing that precipitation was falling through the storm at 2 inches per hour. As a result, flood watches were issued for the United States East Coast and interior areas. NASA's Aqua spacecraft and Atmospheric Infrared Sounder, or AIRS, captured infrared imagery of the hurricane, revealing strong thunderstorms shown in purple. This allowed scientists to predict the hurricane's areas of heaviest rainfall. AIRS also indicated the extent of the storm's reach, shown in blue, stretching from the Carolinas to the Ohio Valley and eastern Canada. Right now, the only human beings living in space are on board the International Space Station. NASA's next goal is to put human beings on spacecraft that will take them deep into our solar system. Today, we are joined by NASA astronaut and mission specialist Alvin Drew from the Johnson Space Center. Colonel Drew has been working on the next phase of spacecraft and equipment that will support future human exploration of deep space for long durations of time.
My name is Alvin Drew. I'm an astronaut mission specialist at NASA's Johnson Space Center in Houston, Texas. Right now I work on a project called the Deep Space Habitat Project, part of a bigger program called the Advanced Exploration Systems Program. The Deep Space Habitat is basically a spaceship. We're looking at how to design parts of a spaceship where people live and work for very long voyages. We're going to go beyond the moon and to deeper space. We may be living out there for 6 months, a year and a half. So how's the best way to make that so you can work and be productive and enjoy the experience? Design always begins with the fundamental question is, what do you want and what do you want it to do? If I build you the best race car in the world and you really wanted a sedan to carry around your kids, I missed the mark. And so the first thing we do is make sure we're headed off in the right direction, because there's going to be quite a bit of effort and energy and money spent on building this. At the heart of engineering is constraints. If your budget was unlimited, your materials were unlimited, of course you'd build great palatial things. We have lots of constraints on us. We have schedules. I can't take until the year 2050 to deliver this. I need to have something out by the end of this particular decade. The next thing is we have different types of rockets that can take you to orbit, but they can only carry up so much weight and things that are so big. And so if I bring something in that weighs 100 tons, well, nothing will get it off the Earth, so it'll sit there. So I need to bring up things that are light enough to go up on these particular rockets. Also, they can't be very wide. Most houses, they're 30 feet wide, in some spots. I don't have any rockets that are 30 feet wide, and they'd never make it out of the atmosphere if they did. Recyclable materials is a big point with us. Long before we had things like green engineering and greenness here on Earth as a big fad, spacecraft and space stations, we're doing this as a matter of necessity. Everything we bring into space with us has to be imported. If you're on a 1.5 year journey to Mars, nothing's going to come out and resupply you for that 1.5 years. So you need to pack everything with you that you can. All of our air, all of our water, all of our food, all of our clothing, every single thing we are utterly dependent on what comes up. And these things sometimes cost between $10,000 and $50,000 a pound to bring to orbit. So obviously, everything that we can reuse saves us lots of time and lots of effort on getting things up to space. Up until recent history, I would say what you could do with leftover materials is pretty limited. You can be very imaginative. You might take the thermal blanket off of an old lunar lander and you could use that to insulate something like that. Or you could take the metal and make a table or something. As a friend of mine once said, if you're living on the moon because of radiation, you don't live on the moon, you live in the moon. That's what protects you from your radiation. So you might take the rocks around you and build up berms or dig a hole and just put your vehicle down inside the surface of the moon to protect you from the heat, the boiling heat of the day and the deep space radiation. So it's wherever your imagination leads you. One of the big things we're working on right now, we're excited about, is this new thing called 3D printing. I don't know if you've seen these before, but you can take plastic and you can print things out of it. You can make things that are three-dimensional. So we have lots of plastic packing for our food, for everything else. What do we do with that trash? Can we now grind this up, melt it down, and turn it back into the plastic wire that feeds the 3D printer, such that if I need a new chair or a new set of eyeglass frames, can I print those out on my printer and reuse my trash? Can I turn it back into something good? So yes, recycling is a big part of how we're going to work and survive on long space journeys.
An important part of any mission is the use and reuse of materials. Remember, as Colonel Drew shared, every pound of equipment and supplies you take up to space requires lots of money and fuel. With that in mind, your assignment is to design a future mission.
Teachers, you and your students will get a real taste of designing a mission for the moon. Look for Pack Up for the Moon Educator Guide. You'll find it on the NASA Explorer School's virtual campus.
Well, that's it for NASA Now. Be sure to visit our Facebook page and tell us about your moon mission. We'll see you next time on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.